Good morning or afternoon, everyone. It is November 21st today, and we are doing Unit 4, Lesson 1. So Unit 4, Lesson 1, let's begin with radian measure. What is a radian? So here we have angles are commonly measured in degrees. Hopefully you remember from last year. But in mathematics and physics, there are many applications in which expressing an angle as a pure number without units is more convenient than using degrees. So when measuring in radians, the size of an angle is expressed in terms of the length of an arc A that subtends the angle theta, where theta is equal to A over R. What does that mean? Well, 1 radian is defined as the size of an angle that is subtended by an arc with a length equal to the radius of the circle. Therefore, when the arc length and radius are equal, theta is equal to A over R, which is the same thing as R over R, which is 1 radian. How many radians are in a full circle? In other words, how many times can arc length equal to the radius fit around the circumference of a circle? We know the circumference of a circle is 2 pi r. So if you use the full circumference of a circle for the arc length, 2 pi r over r, that's equal to 2 pi radians. So basically, a full circle, or 360 degrees, is equal to 2 pi radians. And we're going to be using pi as a symbol to kind of write the value for radians. But just so you are clear, radians is a number. So that pi is not a unit, it's just a way for us to write. The actual number, if we want to evaluate it, is just 2 times pi. So I want to make that very clear. So if you do 2 times pi in your calculator, 2 times 3.14, but remember, in grade 12, we shouldn't be rounding anymore, so we need to use that pi symbol. So if you do it, you should get something along the lines of 6.28318.5. And then so on, because we know pi goes on forever. So that's the actual value. So this is 6.28 radians, or 2 pi radians, because we can write it in terms of pi. Now, I'm going to tell you this ahead of, time. You will learn that sometimes radians doesn't necessarily have to have the symbol pi. You can just have, say, 5 radians, or 2.3 radians. It's just a number. So don't be hung up on the fact that, oh, radians don't have pi's. It doesn't necessarily have to have a pi. All right, one thing to note. A 1 degree is equal to pi over 180 radians. To switch from degrees to radians, we multiply by pi over 180. What does that mean? Well, I'm going to show you an example. But before that, to switch from radians to degrees, we multiply by 180 over pi. So the values, if you take a look at it, they kind of just flipped depending on which direction we're going. So let's do a few basic questions. All right, so let's see if we can convert 180 degrees to radians. So we take 180 degrees and we're going to multiply by pi over 180. And you can see the degrees are kind of opposite sides of the fraction line. So 180 divided by 180 is just 1. So 1 pi radians is the answer when you're converting 180 degrees. What about 90 degrees? Well, 90 degrees, same thing. You take 90 degrees, we multiply by pi over 180, and we get pi over 2 radians. And 60 degrees, same thing. 60 times pi over 180. And this is a nice fraction, pi over 3 radians. Okay, so that's how you convert degrees to radians. You just multiply by pi and then divide by 180. Let us do the next few examples, which are 45 degrees, 30 degrees, and 1 degree. So 45 degrees, same thing. Multiply it by pi over 180. 45 over 180, that is going to be pi over 4 radians. 30 degrees, same thing, multiplied by pi over 180. And that is the same as pi over 6, I believe. Yeah, that sounds about right. Radians. And 1 degree is just, well, pi over 1 over 80. All right, because multiplying by 1. Radians. Okay, so that's some examples of radians and degrees. I'm going to show you some unit circles here. Take a look at that. Okay, so we have 0 degrees, and then we have also 0 radians, or it says 360 degrees, and in radians that would be 2 pi. First line is 30 degrees, so 30 degrees is pi over 6. 60 degrees is pi over 3, or 2 pi over 6. Because remember, you're just kind of doubling 30, right? 90 degrees is pi over 2. 120 degrees is 2 pi over 3. Next one we have 150, which is 5 pi over 6. And 180 degrees is the same thing as 6 pi over 6, which is just pi. And then when you go past 180, 210, that's 7 pi over 6. 240 is 8 pi over 6. But remember, 8 pi over 6 can be simplified to 4 pi over 3. At 270, we have 3 pi over 2. 300 is 5 pi over 3. And 330 is 11 pi over 6. And obviously 360 is 2 pi. So this is just, some basic, angles that we've worked with. I think, yeah, that's pretty much it. Here's another example of the angles that are missing from this unit circle. So, for example, 45 degrees, 135, 225, and 315. So 45 degrees is pi over 4. 90 is pi over 2, still the same thing. 135 is 3 pi over 4. 180 is pi again. 225 is 5 pi over 4. 270 is 3 pi over 2. And 315 is 7 pi over 4. And then 360 is 2 pi. So yeah, some basic examples. And now we're going to convert from radians to degrees. Oh, wait, oops, didn't copy the question down. There we go. Okay. So we're going to convert 2 pi over 3 radians into degrees. And the way to do that is to take my radians and multiply by 180 degrees on top and pi in the denominator. The pi symbols will cancel out. And you're basically doing 2 times 180 divided by 3, which is what exactly? Well, that's probably going to be 120 degrees. So yeah. What about 9 pi over 4? Same thing. Do 9 pi over 4 times 180 degrees over pi. Pi's will cancel out. And you're just doing 180 times 9 divided by 4. And that is going to be 405 degrees. Remember, use a calculator to check. What about 1 radian? How do we do 1 radian? 1 radian is going to be, remember, you're always multiplying by the same conversion factor, 180 over pi. And this is basically 180 over pi. What is 180 divided by pi? So get your calculator, plug it in, and you should get a decimal value of 57.296 degrees. And depending on what the question is asking, you can round to either the nearest decimal place or nearest whole degree. It depends on the question. But yeah, so this is how you convert from radians to degrees. And remember, radians do not necessarily have to have that pi symbol. The first 2 examples did. The third example did not have pi anywhere. This was not 1 pi. This was just 1 radian. And in that scenario, you have to plug in the pi value in your calculator to figure out the exact amount. Okay, let's do some practice problems now. Some application questions. Let's see here. What do we have? Well, we have Suzette. Suzette chooses a camel to ride on the carousel. The camel is located 9 meters from the center of the carousel. If the carousel turns through an angle of 5 pi over 6, determine the angle of the arc traveled by the camel to its nearest tenth of a meter. Okay, this is going to go back to the very initial lesson that we learned at the very beginning. So if you remember correctly, when you're relating an angle is equal to arc length over the radius. And in this case, arc length is equal to theta times r. And if you forgot exactly what is arc length, so let me just draw a circle quickly. So remember, an arc length, if you have from the center and you have an angle, theta, you have radius, and a is your arc length. It's the distance from here to here. That's arc length, okay? It's kind of like an arc, it's like a curved length. All right, so a is equal to theta times r. We know that if the angle is 5 pi over 6, that's theta. It's in radians. And we know that camel is located 9 meters from the center of the carousel. So from the center of the carousel, it's located 9 meters. So that's our radius, in case you haven't figured that out. So arc length is just 9 times 5 pi over 6. And if you do that in your calculator, remember to always put the approximate sign. So approximately a is, or arc length is approximately equal to 23.6 meters. That's it. All right. Some of you, oh wait, no, this is gonna be for the next lesson. Never mind. Yeah, that's it. This is a simple example. Let's move on. Let me see. Application. Wait, what? Oh, yeah. Oh, okay. This is important. Special triangles. Hopefully you remember this from grade 11. If you remember, there was 2 special triangles with 3 different angles. One was the 45-degree angle, 45, 45, 90, right triangle, and then one was the 30, 60, 90, right triangle. And these are special because they gave us exact values when it came to evaluating the trigonometric, I guess, functions for these degrees. Now, instead of the 45, 45, 90 degree angle, we are converting it into... So when it comes to grade 12, just remember, we have the same special triangles, except now, instead of using degrees, we are using radians. So we have a 1, 1, root 2 with pi over 4, pi over 4, replacing the 45 degrees. And then 1, 2, 3, and 1, 2, root 3, pi over 3, and pi over 6. Now, which one is 60 degrees and which one is 30 degrees? So pi over 6, think about it. Is that bigger or smaller than pi over 3? Obviously pi over 6. If you multiply by 180, you'll know that's 30 degrees. And it is a smaller fraction, and pi over 3 is obviously bigger, so this is 60 degrees. So yeah, basic stuff. And I think that is it for part 1. Yeah, that's it for part 1.